first couple sections are just talking about how we deal with triangles. How do we categorize triangles? How do we talk about them? What's the vocabulary that goes with triangles? And then we'll start getting into some more analytical stuff, later on in the chapter. But this is really just an introduction. Okay, so names of triangles, and you've seen this before for sure. I know that going back to middle school, you've talked about this stuff, but maybe it's been a while. Names of triangles. Now we can classify triangles by the sides of the triangle, or by the angle, or we can combine the two eventually and have a little bit of both. So equilateral, as you know, that's just equal. What's equal mean? Same or equal. Yeah, equa means same or equal. And what's lateral mean? Knowing these terms helps in math. Lateral means sides. So when you talk about anything having lateral involved, we're talking about the sides of some geometric figure. So equilateral just says same sides, right? So all three sides are the same. All three sides are congruent. Now, isosceles triangles. There's the little mistake people make with isosceles triangles sometimes. How many sides are congruent in an isosceles triangle? 2 or no? 2 or more. Yeah, it could be 3. Could be 3. In isosceles, the definition of isosceles just means that there are at least 2 congruent sides. It doesn't mean that the third side is not also congruent. So then my question for you is an equilateral triangle also isosceles? Yes. Yeah, it is. It is. An isosceles, equilateral triangle is just a special type of isosceles triangle. Okay? And then scalene just means nothing's the same. None of the sides are the same. So 3 different sides. Okay? Questions on that? All right. An acute triangle. Okay? An acute triangle just means, as you would expect, because we've talked about acute angle stuff, an acute triangle just means all of the angles are acute. Okay? Any triangle where all the angles are acute is an acute triangle. What do they all have to add up to? 180. Yeah, we'll get to that. All the interior angles of a triangle have to add up to 180. Okay. An equiangular triangle. What do you suppose that means? Just based on the word. Same. Equa means same. What's angular probably mean? Same angles. Yeah. So if all 3 angles are congruent, then it's equiangular. Okay. Of course, if it's equiangular, it also has to be acute, right? Because all the angles are 60, which is less than 90. How do we know they're all 60? I just threw that out there. And they have to add up to 180 if there's 3 of them. It's only 3 sides, or only 3 angles that would fit, right? Okay, right triangle we know has just 1 right angle, right? Down here. The other 2 angles in a right triangle, what can you tell me about those? What are some things you can tell me? Say it again. Not necessarily. They could be. They don't have to be. What can you tell me for sure about the other 2 angles, other than the right angle, the other 2 angles in the right triangle? Okay, they have to be acute, don't they? Yeah. How come neither one of those could be bigger than 90? Because one's already 90. One's already 90, right? And there's only 180 degrees to spread around for all the angles, and so obviously neither of the other ones could be, they can't be 90. They have to be less than 90. Good. What else could you do? Well, I guess we sort of touched the other thing also. The other 2 angles have to add up to 90, yeah. Okay, and in an obtuse triangle, obviously that's going to be, if we just follow this progression of logic here, that's going to be the triangle with 1 obtuse angle. But it can only have 1, right? Because if it has 1 obtuse angle, that's bigger than 90, and there's only 180 degrees to spread around among all the angles, and the other 2 are kind of getting shortchanged, right? They're going to have to add up to less than 90. Right? So 1 obtuse angle. The parts of a triangle, I just want to make sure you get this vocabulary down. Each of the 3 points that join the sides we call a vertex, right? So that's vertex C, vertex B, vertex A. If you have more than 1 vertex, you're talking about several vertices. That's the plural. So that's how you spell it, vertices. Two sides. Okay, and then the sides, we know what the sides are, right? The sides are obviously just the segments that we join together to make the triangle. 2 sides that share a common vertex. So if we're talking about vertex A, then we'd say that sides AC and AB are adjacent sides, because what does the word adjacent mean? We talked about that a long time ago. Yeah, next to, right? It means that in everyday life, but in math especially, it means next to. Because these sides are next to each other, they're adjacent. Now, relative to this vertex A, then side BC is the one that's not touching A, and so we call that the opposite side. Okay. What else? I think that's it for now. There. Okay. A right triangle. When we're talking about a right triangle, we have some specific terminology that goes with that. When we're talking about a right triangle, we have, of course, the right angle. And the biggest side, you know this, the biggest side that's opposite the right angle, we call the hypotenuse, right? All right. Pass that back. Hypotenuse is opposite the right angle, and then the two sides that are adjacent to the right angle, we call the legs of the right triangle. In an isosceles triangle, it's a little different. We have the two sides that are congruent, right? And in the rare case, and there could even be three, but typically there's only two. The two sides that are congruent we call the legs, and then the other oddball side we call the base. And so what's useful to do with these things is, at least in your mind, you're going to play lots of mind games with these shapes now. We want to pick the triangle up, and we always want to set it on its base in our mind. Okay, so that base is on the bottom, and the legs are congruent, and they poke up from the, you're setting it on the coffee table. The base goes on the coffee table, and the legs poke up towards the point. Okay? Okay? Okay, so now, what about this one right here then? We've got triangle ABC. So, why is it an isosceles triangle, first of all? Okay, it's got two congruent sides. We know they're congruent because their lengths are equal. Okay? It turns out in this case that, it's not exactly. If that's truly 7, it's got to be something a little bit bigger than 7, but the 7 point something. And this is also a right triangle. Now, is that okay to have a right isosceles triangle? It seems like maybe at first, maybe not. They're different things, but they're not, because those were two different ways of categorizing things. Right? Remember, we categorize triangles by the sides. It's isosceles, right? Because the sides, two of the sides are congruent. And then we also categorize triangles by the angles. That's a separate issue, right? That would be like saying that if I'm talking about a dog, I could say that that dog is a black male dog. The fact that it's black and it's male, it can be both, right? They're both different ways of describing the dog. Saying that this is a right isosceles triangle just gives me different pieces of information that describe the triangle. Isosceles refers to the legs. And the right part means it's got a right angle in it. Okay, so yeah, it is. It's a right isosceles triangle. It gets really specific. Okay? Somebody name one of the legs of the isosceles triangle. Raise your hand. Somebody help me out. What's a leg of the isosceles triangle? Yeah. Just like you name a segment. Okay, so side CB or segment CB, right? Good. Okay, somebody name the hypotenuse of the right triangle. What do you think? Yes. Oh, yeah, too bad. Raise your hand.
No,
What's the hypotenuse? Hypotenuse of the right triangle.
I don't even know what you're talking about.
Hypotenuse, right? That's opposite the right angle.
I don't know.
Okay, somebody help her out. Yes. Segment AB or side AB, right? Because it's the side that's opposite the right angle. Okay. All right. So this is the hypotenuse of the right triangle, the base of the isosceles triangle, and these are the legs of the isosceles triangle and the right triangle. Okay. Questions on that? Okay. In this first assignment, there's just a lot of vocabulary stuff.
I like the heart.
You like the hearts. I didn't choose the hearts, but they're nice. Okay, so using angle measures of triangles. Now, in this case, I don't know why the hearts and the smiley faces, but we'll just go with it. The smiley faces are the interior angles of the triangle because they're on the inside, right? Interior means on the inside. So there are going to be 3 of those, obviously. Now, the hearts represent what we call exterior angles. Okay, now exterior angles, I gotta describe this a little bit. An exterior angle is what you create if you take a side of the triangle and just keep going, just keep extending it. So for example, if I take side AB and I just keep going with that and make a ray out of it, I'm going to create, I'm going to create 2 things. I'm going to create a 180 degree, if we're talking about vertex B, I've got a 180 degree angle that we're going to ignore. We don't care about that one. But the angle that's less than 180 degrees, that's the one we're referring to. So this is the angle we're interested in, angle B. That's what we call an exterior angle. Okay? Now I could create 2 of those for each vertex, couldn't I? I could create the one that's drawn there, or I could have also, you might be asking, well, why is AB so special? I could have started at C and extended that side as well, right? And then my exterior angle would have been right there. Does it make any difference? How come? It doesn't make any difference. You're right. How come? Because they're the same. Exactly. Whichever one we want to draw on the paper, it doesn't matter. And we're going to call the exterior angle. Whichever one we choose doesn't make any difference because they're vertical angles and they're going to have the same measures anyway. They're congruent, right? So when we talk about an exterior angle at vertex A, draw whichever one you want. It doesn't matter. But just pick one. You can't draw them both. Just pick one. Now there are some properties of these things that we need to be aware of. I'll go to the next page with me. Okay, the exterior angle theorem tells us that if I've got this triangle like so, and I extend the base of this thing, right? So I've got interior angles 2 and 3, and I'll even put 4 in there. How about? So there's 4. And then I've got this exterior angle 1. What the exterior angle theorem tells us is that the measure of the exterior angle is equal to the sum of the measures of the remote interior angles. Now that's a lot to say. What do I mean by that? Well, the measure of angle 1 equals the measures of angles 2 and 3. We call those the remote interior angles because what does the word remote mean? If you're in a remote location, what does that describe? Far away. Yeah, it's out in the boondocks, right? In the middle of nowhere. So remote means far away. So we're going to add up the 2 angles that are far away from that vertex, and their sum always is going to equal the measure of that remote, or that exterior angle. Okay? All right. So we could use this to solve an algebra problem. This is the kind of stuff you're going to be doing. So what if we knew, for example, that this interior angle had a measure of x, that one's 65, and the exterior angle has a measure of 2x plus 10. You get probably used to doing this stuff, right? All we're going to do is we're going to come up with a geometry relationship here that allows us to make an equation. Well, this is the exterior angle here, isn't it? We know that 2x plus 10 would have to equal the sum of those 2, so x plus 65, and then you're just doing algebra, right? Collecting all the like terms and isolating x. You're going to get really good at that. Okay? I think that just about does it. Oh, a little corollary to this. We've already talked about this. Corollary to the triangle sum theorem, and that's the one that just tells us that all the interior angles add up to 180. You know, we already said that if it's a right triangle, the 2 acute angles have to add up to 90, right? So if I knew that this was 2x and that was x, and I wanted to solve for x, I know they have to add up to 90. So 2x plus x equals 90. Solve for x, right? No biggie. Okay. And once we know that x is 30, that would tell me that's 30 and that's 60, right? Okay. I think we're good to go. So I've got the first assignment I will put up there. How many people, I need to show of hands here, how many people do not have a textbook checked out to them? Because you're going to need textbooks on this chapter 4 stuff. So raise your hand one more time. Who does not have a textbook? Everybody in here's got one? Okay. All right. I got to see here. Hang tight for 1 second. I'll tell you. Okay, I think we're okay to go to room 205. Gabby? We were just in the lab yesterday. We're gonna do some new stuff today, but we just were in the lab, so you didn't really miss anything. Yes, you betcha.
Thank you.